page, go fund my class favors. Okay.
I want a bagel breakfast.
Now, the first thing, excuse me, the first thing I would like to do is go into last night's homework, and I want to do these two questions. Okay? So if you would get your homework out, please. I want to make sure we're good on all of this. And then, as far as today's lesson goes, I think today's lesson is very easy. So, everybody have their homework out?
No.
Kristen, how are we looking with that homework? You should have it out, right? Yes. That's not last night's homework? Oh, that's tonight's maybe.
That's classwork.
Oh, that was classwork? We had no graphs on it?
Except that one.
Yeah, besides the one on the back.
But it wasn't like what we did.
That's fine. Yes, it is. Yeah, that's fine. We'll go over this one. Thank you. Okay.
Oh, yes, it was.
Now, even better, because I only wanted to go over one, and I found two, so this is an even better situation for us. All right. Now. Okay. Listen, it's really, really, really important that we get focused right now, and that we are ready to rock and produce and so on and so forth. I keep looking at that test that we have before the break, and I'm saying to myself, between the good grades we got on the last test and the kids who are going to get their relearn packets done, plus the next test, you guys could go into the Christmas break with a really solid foundation toward getting a very good grade in the second market grade. And that's, I would like to be there with all of us. And I really don't want, I will have stuff prepared for a relearn packet over the Christmas break if you want to do it, but I hope that nobody has to do a relearn packet over the Christmas break. I hope during the Christmas break nobody picks up anything related to school, and that you just clear your head and really just enjoy the time with your family. What's that?
With her take-home test. With the 35 question take-home test.
All right, hey, hello, hi.
Finish the book.
But in order for that to be the case, you're gonna have to do well on that test before Christmas. So, you know, the thing is, you don't wanna stress over it. A tiny little bit of stress is a good thing. It just kinda keeps you sharp. But too much stress is a horrible thing. And I don't ever want it to be stressed in here. I want it to be fun, with an edge of purpose, so that little tiny bit. But there has to be this sense of, if you do what you're asked to do, if you prepare the way you're asked to prepare, that there's a really good chance you're gonna produce a very good grade. That's how we should come into the room every day. All right, so graph the points 2, 3, 2, 3, and 1, 0. Okay, so the first thing I noticed with this is, because obviously the y-intercept is very important, I noticed to go from this point to this point, it's up 3/1, so I'm gonna go right there, just so I can mark my y-intercept perfectly, because that is such an important point. What's the slope of the line connecting the 2 points? 3/1. By looking at the graph, what's the equation of the line? Y equals 3x minus 3. Everybody agree? Mm-hmm. Okay, good. Now, that should be, we would call that finding the equation by inspection. Inspection means to just look at it, get it right. Now, I want to be able to do it analytically, all right? It is important that you develop this skill. As soon as they want it to be done analytically and they're writing the equation of a line, or you're writing the equation of a line to be more precise, I'm thinking y equals mx plus b. And if I can find m and I can find b, I can get the answer correct. Well, I can use the slope formula with the 2 points that I'm given, here and here. I don't care which is point 1 and point 2, but I do prefer, it doesn't have to be, I do prefer to subtract in such a way that I get the y's to be positive. So by making the point on the left, the 2, 3, the second point, I'm going to get 3 minus 0 over 2 minus 1, which is 3/1, which is 3. So that means, so far, my equation is y equals 3x plus b. Are we all good up till here?
Yeah.
Okay. My personal opinion, having taught this now for, I guess this is my 32nd year of doing this, is that every student is very, very good up until this point. The next step, you will all get good at, but sometimes it takes a little light bulb going off. Kaylee?
So like, for the first part of the question, where it just says to write the equation in the line, not like analytically.
Right.
Do we write plus b, or do we have?
You include the y-intercept, the actual numerical value of the y-intercept. Okay, in this case, -3. AJ?
So what would happen if you like, it was at like an ugly point where you really determine what's going to do that?
Well, now you have to do it analytically. You don't have a
So
choice.
like,
You
but
put plus B.
you put, yeah, would you put plus b or would
No, you gotta figure the value out.
And then.
And you can't do that by inspection. You have to do that analytically. Okay?
okay, so for b, what would you put down?
I'm gonna keep going in a second. Now, so what I was saying a second ago is, my opinion, every person in the room finds up until here easy. The problem is the last part, finding the B. And to do that, sometimes things are too obvious. The problem is, as I look at this, a single linear equation, y equals 3x plus b. I have three variables in one equation. I have y, I have x, and I have b. I can't determine b when there are three different variables in a single linear equation. So the question is, how can I get rid of 2 out of those 3 variables so that I can find b?
You substitute X and Y.
That's right. Now, here's the problem. You do substitute x and y, but nowhere in this problem does it say, hi, x is, y is. It doesn't say that, but it still says that.
What?
It's the coordinates. Isn't any coordinate x comma y?
Yeah.
So therefore, here's my x and y, or, if you wish, here's my x and y. I don't care which point you use, they both lead to the same solution. But they don't come out and hit you over the head and say, Sydney, x is 1, y is 0. They don't do that. You need to say, you can't fool me. I know what the x is, and I know what the y is, because I knows that that's an xy coordinate. All right. So, I'm going to use 1, 0, because, why? Because I like 1s, and I like 0s, because they're easy. Y is 0, x is 1. 0 equals 3 plus b, minus 3 minus 3, b is -3. Now, AJ, at this point, you have b. You come in, you put it back in. Y equals 3x minus 3.
Hey, that's what I got.
Excellent. There's my solution. And of course, that matches what we got by inspection. Okay?
You said, B.
All right. Spencer?
So are we assuming from this that we already know what the MX part is, and we're just trying to find B?
Well, you're only going to know the MX part when you find the M.
Okay.
Any other questions? All right. So that was the gist of yesterday's lesson and the day before's lesson, because remember, it was a 2-part lesson. And I consider that a pretty challenging question, one of the more challenging lessons, I should say, of the year. So I don't think it's overly hard, but you need to work at this. This is not the kind of thing where most kids look at it and go, I got that. It just generally doesn't work that way. So you'll notice that you'll have one of those on your homework each night for the next probably week or so. Speaking of homework, Sarah E., I'm glad you're writing all about Paul. This is a beautiful thing, but it is not done during math class. All right. Oh, it's even graded already? All right, so.
Potato?
Oh, she's talking about her potato.
No.
She crushed it.
This is for Spanish.
All right.
Why? It like flew near my locker.
Can we all get our head in the game here? Yes.
Which one is that?
This should be today's sheet.
It says +4 on this.
On the sheet today, it says +4?
I think this is yesterday's.
No.
I don't think so, because it's.
No, that's different.
All right, so is it x plus 5, y minus 2, x plus 4?
Yeah.
Okay, good. So as we did yesterday, I'm going to cover this up. Well, first let me draw a picture.
It's x minus 2.
Yeah, it's X minus 2.
X plus 5 times x minus 2 times x plus 4.
Good, okay. So, as I did yesterday, we draw the picture, it's 3 dimensions, x plus 5, it doesn't matter which dimension is which, x minus 2, x plus 4. This is going to be a little nicer than yesterday's, because it's just one variable, okay? I'm gonna cover up the x plus 4, I'm just going to double distribute these two on the left, and when I do that, I'm going to get x squared plus 5x minus 2x, that order's backwards from usual, which gives me x squared plus 3x minus 10. Everybody get that? Right, I've graded a lot of your papers, you're very good at this.
X squared.
Plus
Yeah.
3x minus
Yes.
10. We're good, right?
Yes.
Okay, but now we're kicking it to the next level, which I still think we're pretty good at, but I want to make sure that we do. We're now going to triple distribute.
Dad.
X squared times x, x cubed. X squared times 4, 4x squared. Now I do the 3x. 3x times x, 3x squared. 3x times 4, 12x. Now I do the negative 10. Negative 10x minus 40. Combining like terms, x cubed plus 7x squared plus 2x minus 40. Sweet. Yes?
So it's the same if you distribute the x and the 4.
Yeah, if you worked it backwards, it would be exactly the same. Now, Evan brings up a really good question. He says, what if I distributed the x and the 4? That is an example of the commutative property. Because the commutative property says it doesn't matter if you switch order. So I could do the whole trinomial on the left multiplied by the binomial on the right, or I could do the binomial on the right multiplied by the trinomial. Since it's multiplication, it better work out to be the same, or we're doing something wrong. Janelle?
I messed up at one point. I said I forgot to combine like terms in
Okay.
the top one. But then I got the right answer. Is
Yes,
that,
it
that
would
always
still work. Yes.
Like let's say if I see on a test I keep making a mistake and I'm like, oh, should I go back and fix it? Should I fix it?
The answer is, if you get the right answer, you get the right answer. However, you've made more work for yourself.
Yeah,
I'm sure
but-
yours looked uglier.
Yeah.
Yeah, all right. But you would get full credit.
Okay.
All right. Anything else? All right, so let's go forward to what we're going to talk about for today's purposes. Find the slope of the line connecting the 2 points. Well, let's see you guys graph these 2 lines on here. Go ahead, do that. Nice easy question with which to begin the lesson for today.
Are you kidding?
Okay, so if I graph the first line, y equals 2x minus 4, what I notice is that the slope is 2 and the y-intercept is negative 4. So I go to negative 4, that's where I begin, up 2 over 1. And there is my graph of y equals 2x minus 4.
2 over 1 over 2 over 1.
Okay.
Really
All right. Now, let's graph the next one. What's the slope here?
No,
What is it?
2.
2. What's the, not x, just 2. What's the y-intercept? 1. So I begin, begin, 1, up 2 over 1, up 2 over 1. We used to have a math teacher in school named Begin. So I go, begin. Really did. And then he has a brother who still teaches at the high school. This is y equals 2x plus 1. Okay,
That start.
now, what do you notice about these 2 lines? Right?
They're parallel lines.
They're parallel. Now, what makes them parallel? Do the y-intercepts make them parallel, or do the slopes make them parallel? And the whole class said?
Slopes.
Slopes, good. So what do the slopes have to be for the lines to be parallel? Spencer?
Equal.
Equal. Anytime we have equal slopes, we have parallel lines. Now that should make sense, because look, if I begin here, up 2 over 1, up 2 over 1, up 2 over 1, if I begin here, up 2 over 1, up 2 over 1, up 2 over 1, either way, because they're both going up 2 over 1, they'll never touch. Bless you. They're always going to follow the same path, so to speak. All right, let's see you guys graph y equals 1/2 x minus 3. Go ahead. Okay, now looking at the next one, what's the slope?
1 over 2.
1/2, good, and what's the y-intercept?
Negative
-3. So I begin at -3, up 1 over 2, up 1 over 2, up 1 over 2, and so on. Now the next part says to graph a line parallel to this. Does it matter what the y-intercept of this new line will be?
No.
No. Does it matter what the slope will be?
Yeah.
Yes. What better the slope be?
1 over 2.
Of 1 over 2. Go ahead, make up your own one.
We have to make up our own rule to.
Your own rule?
Yeah, like our equation for the thing.
Oh, yes, your equation, yeah. Okay, so I don't know what line you chose to make, but I know that my personal favorite number is 3. And my second favorite number is 7. God bless. So I would have chosen a y-intercept of either 3 or 7. In this case, I'm going to choose 3. Actually, I take it back. I'm going to choose 7. 4, 5, 6, 7. The reason I chose 7 is my most hated number is 6. I despise the number 6 because it's like 666, devil, all that kind of stuff. So if I made the dot here, I would be a distance of 6 units away. I don't want to be 6 units away. If you ever have to take one of my tests, and you're ever stuck and need to guess, the very last number you should ever guess is 6. Because I tried very hard to never make an answer with 6 in it. So just a little word to the wise. I don't necessarily try to make 3s or 7s, but I never, ever, if I come out with a 6 as I'm doing it in my head, I will say to myself, change the question. I don't like when 6 comes out. But that said, most of your tests are made up of old Regents questions, and if theirs works out to 6, then it works out to 6. All right, so anyway, slope up 1 over 2, up 1 over 2, up 1 over 2, and a little bit continued on the backside. And there is my line. Yours can have any y-intercept you want, as long as you see by looking at your line inspection, if you will, that they are parallel. Any questions? All right. What's the most important thing we've learned so far?
Slope must be the same.
Slope must be the same for what?
For 2 parallel
To
lines.
see if 2 lines are parallel. Okay. Show with 2 different techniques if the line connecting is parallel to the line connecting. Go ahead. See if those lines are parallel. Okay. When you graphed it, were they parallel? No. No, they're close to it, but if you kept this line going, and this one, they would eventually cross. And that's one of the advantages to the formula. If you look at the formula, I come out with 3/2 and 2/1. So clearly they're not the same, agree? And if they're not the same, they are not parallel. We good? Yes.
How do you know what to go up by? The line, because I didn't know what to do.
The negative one.
Well, I went and I plotted these 2 points.
Mistaken.
So I said, how do I get from here to here? I go up 3/2, so I just repeated it, up 3/2, up 3/2.
Is it always the same as the point that you made?
Whatever the slope is between any 2 points is the same everywhere on a line.
Okay.
It never changes. Lines always have constant slopes. Okay, now, let's take a look at our last idea of the day. See if we can figure out 2 ways to answer this question. Lines A and B are parallel. The slope of line A is 2/3. The point -3,5 is on line B. What is the other point on line B so that the lines are parallel? See if you can figure that out. Got about a minute, a little over a minute. A and B are parallel. This aligns somewhat with what Sid just asked about. Okay, so, there's the point -3,5. It says the slope of a parallel line is 2/3. So if the parallel line has a slope of 2/3, what does the slope of line B have to be? 2/3. So I can go up 2/3, up 2/3, up 2/3, or I could have went this way. As long as that slope, so you could choose any point anywhere along that line, and it's the correct answer. AJ?
How do you divide it?
Well, I didn't ask for the equation of the line, did I? It just said, what is the other point on line B so the lines are parallel? So the answer is any of these points. It could be 0,7, but it could also be 3,9. It wants the other point. It doesn't want the equation of the line.
Okay.
All right? All right, so keep up that work on the relearn packet. I will be here tomorrow morning. I will not be here Friday morning. Friday is breakfast at Bruno's, which is now a thing. And we'll get things going. Let's get that other retest done, producing the kind of grades that you expect to get.